All right, we're looking at this function f of x. It's a rational function. It's kind of like the one I had on the board yesterday. I know it's different. And we're just going to go ahead and analyze this function, put down all the information about it we can, and then sketch a graph. So take a minute right now. I'll just kind of pause here for a minute for you to write down some information: zeros, holes, vertical asymptotes, and I won't give you too long. I'm going to post this on Google Classroom as well, so that if anybody wants to, look at it on your own time, you can. Obviously, you can pause here if you're looking at it yourself while you work on it. And if you're watching this in class while I'm absent here, just I'm going to kind of talk through what I'm doing. Try to keep working along with it yourself as well. The first thing you want to notice is when you, I think when you're looking at the zeros at the top and bottom, kind of look for any holes first, because those are where you have a zero in both the numerator and the denominator. And oops, we got x minus 3 on both top and bottom there. And because it's in both, it's just a hole, right? It's not a vertical asymptote and it's not a zero. So it's good to make a note of that first. Now I wrote x equals 3. Honestly, though, that's really not the best way to write it. The hole has an x coordinate. It also has a y coordinate. So I'm going to go ahead and put it as an ordered pair, 3 comma something. We'll figure out what that is in a minute. And then I'm thinking zeros. And if you remember, yesterday we were looking at this, and it makes sense too, right? It's a fraction. If you want the whole fraction to equal 0, you want the numerator to equal 0. So you set the top equal to 0, 2x minus 5, right? Any factors on top that we didn't already kind of take care of with the whole. And so there's only just that one. 2x minus 5, set it equal to 0, and solve. You'll get 5 halves, right? So that is the point 5 halves, comma, 0, right? It's a 0 or an x-intercept. I feel like that looks like a 10 instead of a comma 0. Let me just make that clear. There we go. And then vertical asymptotes are the zeros of the denominator. So 1 and negative 2, right? Again, x equals 1, x equals negative 2. Those are vertical lines that kind of inform our graph. Now, for the y value of the whole, you can actually rewrite this function by sort of canceling out the x minus 3 factor. And what'll be left would be the 2x minus 5 over just the x plus 2x minus 1. And those are, I'm saying those are equal, those are almost equal, right? Those two things, f of x and the expression I just wrote, those are equal at every single point except x equals 3. At x equals 3, this function is undefined and this function is not. So I can't just say they're equal. I need to have a stipulation there. I need to say where x does not equal 3. Because at x equals 3, again, the one of them has a hole, the other one doesn't have that hole. But the beauty is, since this one does not have a hole at x equals 3, I can actually just plug 3 into it, and that tells me where the hole is on the other one. So when I plug 3 into that, I'm going to get 6 minus 5 on top divided by, what's that, 5, and that was minus 1, so 2, 5 times 2. So I actually get 1/10 is the y value of the whole. Okay, so I've got some important information there. Again, all this stuff was found by just looking at the zeros of the numerator and the denominator. Another thing we can find pretty easily is the y-intercept. And for that, we're just going to plug 0 in for x. And you don't need to do it in this form, right? You can, but it's easier. The x minus 3s are going to, again, cancel each other out, right? So you may as well just go to the simplified version that we already worked on. If I plug 0 in there, I'm going to get negative 5 on top, and I'm going to get 2 times negative 1 on the bottom. So f of 0 equals negative 5 over negative 2, which is 5 halves. So that's actually going to be the point 0 comma 5 halves. Not to be confused with this 0 we had at 5 halves comma 0. Those are both points on this graph, 5 halves 0 and 0 5 halves. All right. One more important detail before we graph. The end behavior, right? You want to think about the limits at infinity. The limit as x approaches positive infinity and negative infinity. And for that, we wrote some rules on the board the other day, and we'll look at this a little more tomorrow too, but we have a quadratic on top, right? Second degree. On the bottom, we have a cubic, a third degree. And so, since there's a higher degree on the bottom, that means when x gets really, really big, the bottom grows bigger faster and much faster, right? So when x gets really, really big, the whole thing is going to have a much bigger denominator than numerator. It's going to get really close to 0. And so that gives us the horizontal asymptote at y equals 0. Okay, and that's on both ends. Both ends it's going to approach y equals 0. You can write that as a limit by saying the limit as x approaches infinity or negative infinity. I'll say plus or minus infinity of my function f of x is 0. And so when I graph this, I'm going to have a horizontal asymptote at 0, y equals 0. I'm going to have vertical asymptotes at 1 and at negative 2. And I've labeled this stuff. It's kind of hard to on this small screen, but I have 0 at 5 halves, which is 2.5, right? So that was 1, there's 2, there's 3, so 5 halves is right in there. That's a point on my graph. I have a y-intercept at 5 halves also. So I'll just kind of use the same scale-ish here. That's 1, 2, 3. There's my y-intercept at 2.5. That's a 2 and a 3. I'm trying to scale my y-axis there. And I have a hole at 3 1/10, which is going to be right in there, but a little lower maybe. It's hard to write that precisely on this iPad I'm using. But yeah, so I'm going to pass through that 0 right there and that hole right near it. That should be closer to the x-axis because it should be at 1/10 and 1 is there. So it's going to be pretty low. And then, yeah, I think we're good. I think we're ready to graph this thing. So here's what's happening. If you look over at the right, we've got these 2 points here, right? Well, a point and a hole. We're going to have to kind of hit both of those with the graph. So my instinct is telling me that it's probably going to do something like this and then come back down to the horizontal asymptote. Now, if you're wondering how do I know that, well, there's a few things. One thing is we can actually test values, right? We can plug in like 1.001 and probably think about it right here. And if we do that, if we plug in 1.001, you really only need to worry about the 0.001 part when you're looking at the x minus 1 factor. For the other ones, you can just kind of plug in 1. So if I plug 1 into 2x minus 5, I get 2 minus 5. That's a negative value, right? So I get a negative on top. And then on the bottom, if I plug 1 in there, that's a positive. And then if I plug, again, 1.001, a little to the right of 1. If I plug that into x minus 1, that's going to give me a tiny positive number, right? Like 0.001. So the whole thing is going to be negative. A negative over a positive times a positive. That's what that's doing for me. You can actually make a whole sign chart for this thing if you want to, and it does the same thing as what we're doing. So just getting my marks out of the way there. What that means is that this graph goes down toward positive infinity here, or sorry, down toward negative infinity on that side of that vertical asymptote. We're going to come up through that 0. We're going to hit this hole, And then the other thing is we have to come back toward the horizontal asymptote. So we must come up and then back down. I don't know exactly where it turns. I don't know where that maximum is going to be without using a calculator or doing some calculus. That's something we'll learn another time. But we do know that it has to kind of turn and come back down toward the horizontal asymptote because this function has that horizontal asymptote and it's valid on both sides. Okay, so that's the whole right piece there. It kind of comes, again, this is the basic shape of it. It kind of comes up and then back down toward horizontal with a hole there at 1/10. That's the basic shape that's happening there. We also know at x minus 1, that factor, it only occurs one time, right? It's x minus 1 to the first power. So if you did a sign chart for this whole thing, if you just think what's going to happen when I cross x equals 1, right? If I plug 0.999 in for x, 0.999 minus 1 is negative. When I switch over to 1.001, 1.001 minus 1 is positive. So I'm going to have a sign change when I cross x equals 1, right? The entire sign of this thing is going to change. This is the only factor that will change signs when I cross x equals 1, and it will change signs. Now, if I wanted to put a 2 up there as like an exponent, if I squared it, then it wouldn't change signs, right? Then I'd have x minus 1 squared. That would always be positive, except at 1 where it's 0. But since it's not squared, since it's to an odd power, since it's just x minus 1, I do change signs there. That means since I'm going down to negative infinity on the right side of it, I must be going up to positive infinity on the left side of it. And so that's what the graph's going to look like over there. I'm going to come down from positive infinity. I'm going to pass through that y-intercept at 5/2. Sorry, it's kind of hard to hit that precisely with these tools. And then I'm going to have to go toward this vertical asymptote at -2 one way or another. And I guess I want to ask you guys, am I going to cross through 0 here and go down? The answer is no. If I was going to do that, I'd have to have a 0 that I can see in the numerator between -2 and 1, but I don't. I don't have that, right? The only 0 I had was at 5/2. That was this point here at 2.5. I don't have any other ones in this interval. So that means this graph in the middle, it's not going to cross the x-axis in there. So that means it's going to have to turn back around somewhere and go up toward positive infinity at that vertical asymptote at -2. And then at -2, since this factor, again, only occurs one time, just like the x minus 1 factor, that means I am going to have a sign change at -2. When I go from from negative 1.9999 over to -2.0001, I will change signs. So if it goes up to positive infinity on the right side, it's going to go down to negative infinity on the left side. And finally, way off to the left, there are no zeros in here. My function does not change signs in there. The only way to finish this graph then is to have this function approach that horizontal asymptote from below. So that's what it's going to look like. Now, if you're not used to thinking about it the way that I just talked about, that's fine. The way I just talked about thinking about it, though, that can be really quick if you understand it. Like, you can go through this, and honestly, once you write all your details, you can graph this thing in like a half a minute if you understand everything I just said. But if you don't, you can still use those techniques you learned about in pre-calc and algebra 2. So you can plug in a really large x value into this function and see, is it going to be greater or less than 0? It should be a small positive value. That's how we know we're approaching 0 from above that way. You can plug a value a little more than positive 1 in, right? 1.001. We kind of went through that. And that'll tell you that this function goes down toward negative infinity there. And then you can plug a value a little less than 1, like 0.999 in for this whole function for each factor. And you'll see that it's positive and it approaches positive infinity. And that's why we go up here. And then you can plug in a value like negative 1.99999 and you should get positive infinity. And then you can plug in negative 2.0001 and you can tell that it's going to be a big negative number, right? A close to 0 on the bottom and negative overall, which makes it go to negative infinity. And then you can plug in negative a gazillion or negative 100 or whatever into the whole thing, and you'll find that you get a small magnitude negative number, right? Something close to 0 but negative, and that's how we know that it does this over here. Okay, so all those tricks still work. I'm just trying to give you some more tools in your toolbox. Like, think about sign changes. Think about what that sign chart would look like. You can even make the sign chart if you want, but you don't have to. You can just kind of think about each factor and what happens there. Anyway, I hope that was helpful, guys. Sorry I couldn't be there with you today. I think I'll be there tomorrow. I had a sick kid, so we'll kind of see, but I think I'll be able to be there tomorrow, and we can go through another example together, a couple of them. All right. Work on the assignment I'm giving for you. There's a couple functions to graph, and good luck. We'll talk more tomorrow.